Greetings, ladies and gentlemen. Welcome back to the shop. I have something quick for you today that I have to share that I just think is totally just cool, just really neat. I think as whether you're an amateur machinist or a professional machinist, if you have an appreciation for not so much techniques but just contrivances, contraptions, methodologies that have just, you know, sprouted from people's minds over the years. I can think of lots of them. And one of them is the harmonic drive, where you have one or two more teeth in one part than you do in the other. So you have a differential. And that differential allows a difference in angular velocity as things rotate. So you have a gear ratio. You can get tremendously high gear ratios with just a few parts. And I just think they're neat. I just think they're absolutely fascinating. The whole concept. Now, harmonic drives typically are it's an eccentric, a gear within a gear, and to run at high speed, you need two of them to give you balance and all of that. That's fine. But then there's this version of the harmonic drive known as strain wave gearing. And so here's what I want to show you. This is a fixture. I guess I'm going to tap that off. Okay. This is a tilting fixture which holds a rotary table. So here we have a rotary table, and we're able to tilt that rotary table at whatever angle we need in this gimbal fixture. There's a plate that joins these two pieces together, and the rotary table sits on that. Okay, so I've got that apart. So we have these two suspension arms, I guess, that hold this. So one of them is free to spin. It has an encoder that attaches to it, so you can plug it into your digital equipment. And now, how do you position this? And this is where this gets really, really cool. And I'm going to work backwards a little bit, or maybe not. Maybe I'll put it together and I'll take it apart so you can discover it as I did. So here's the plate that holds your rotary table. So this plate is screwed in, so it can't turn. So this can't turn. But I notice, if I actually tighten this up, I notice that there's a little bit of slop in here, and I'm saying, well, that can't be right. So some ham-handed gorilla obviously did something to this that caused it to be sloppy. It was no longer holding tolerance, and consequently was no longer of any use to whoever was using it. So now I look at this knurled ring and I'm saying, well, how does that knurled ring work? I'm thinking that a motor attaches there or something. So I loosen up this knurled ring and I start to turn it, and it's kind of jumping around. But as I turn it, this is turning very slowly. So now I got it all back together, and I've got it readjusted to where it actually works smoothly like it's supposed to. So what happens is you turn this ring. I'm going to try to get my hand out of the way here to show you this. As I turn this ring, you'll see this turn. See this plate turning very slowly? It's quite a reduction. And there's no backlash. I mean, there is no, well, there is backlash because this thing is screwed up. Somebody damaged it. Okay, we're going to fix that. But as I turn this ring, I get this very precise movement. Infinitely adjustable. No backlash. When I'm done, when I get this to where I want it, there's a couple of set screws in here. It's a split ring. And it locks it tight, and you're done. Very cool. My God, how does that work? Now this is made by a company called HDI. Harmonic Drive, I assume it's Harmonic Drive Inc., but HDI. Okay. So you're looking at an exploded view of this Harmonic Indexer. And there are two splines, the D spline and the S spline, and they have a differential in teeth. One is 202 and the other is 200. So there's a 1% difference between them. And the flexible spine, the flex spine, is 202 internal teeth. And the way this works, the wave generator adjusting nut actually applies pressure, and I'll show you this in the video in a moment. It applies pressure at two opposite points, keeping the teeth firmly in contact with the teeth of the gears. And as the flex line is rotated, it sort of makes like a wave motion, moving the teeth around. And for each revolution, the tooth will advance one tooth in the gear that is one tooth short. And so you will begin to see a very slight differential creep between the D spline and the S spline at a 100-to-1 ratio for every rotation of the wave generator adjusting nut. And the dimensions are fairly critical to actually maintain zero backlash, but it does so quite nicely. It's pretty cool. So let's go back to the video and show you what that actually looks like. So this is the strain wave adjuster, and you'll notice the support for the bed rotating. It's about 100-to-1, and I went through quite the machinations to get this thing apart so we can show you just how this works. So now we're going to do that. We have two, I guess you'd call them gears here. The one with 202 teeth, and the other okay. So what was wrong with this? If you can see, this screw is bent. One is actually one actually broke, and so this was not properly locked to the plate. that was attached to the frame. So there was slop in the action, and of course the machine was useless. So now let's get a real good look at how this works. This is what they refer to as the strain wave, I guess, gear. It's a ring gear. 202 teeth. Matches the 202 tooth gear that goes inside of it, but they're not quite the proper fit. So this is going to be, I'll show this to you. When I place it into this ring, it's going to be squeezed on two sides. So hopefully you'll see just below, you can see light coming through the gearing. You can, there you go. You see where the gears are not making contact with the inside and outside. And the same thing occurs 180 degrees. Just fell out on me. Okay. 180 degrees away, the same thing occurs. You see light through the gearing there. But at these 2 points, they are in full contact. So as this ring rotates, it pushes those teeth into the gear around and around and around. Now, on the side where you have 202 teeth, both inside and out, no motion occurs. However, where you have only 200 teeth, every time you travel around, you advance by one tooth. And if I line up, let's see if I can do this. Okay. If I line up those keyways in there and rotate the ring, one revolution. Probably can't even see that. Well, they're a little bit offset. Let's do it again. Now they're offset just a little bit more. Let's go 5. That was 3, 4, 5, 6, 7, 8, 9, 10. And see how offset we are now. Quite a bit. I think I dropped it out. I might have dropped it out. Yeah, I did, because the ring slipped out on me. Alright, so this is all supposed to be held together with spring circlips, inside clips, and the like. But you get the idea of how it works. And when you're done making your adjustments, you lock up the screws, and that's it. There's no backlash. When this is adjusted properly, these teeth mesh without any slop. And this is I can feel a little slop in there, but this will all get adjusted up once I get it all back together. It was really a tough thing to get apart, and when I did get it apart, it was really dirty and filthy and full of grease, and some of the grease had turned to wax, and it was not pleasant. So it's going to need some cleanup. I got to find some replacement 832s here and get this thing all back together properly. And as you might expect on any piece of equipment in the shop, it had this little bit of the shaft was sticking out into into free space, the danger zone, and it got a little banged up, a couple of dents and dings, so I had to stone off some high spots. And this bearing has a little tiny bit of slop in it, but once you attach the bottom plate between these two, it's quite irrelevant. It's there's no real slop to be felt. This goes together pretty tight, dowel pins and all. So there you go. Strain wave reduction gear. It's called an Infinit Indexer. Infinite is spelled without an E on the end, made by HDI. Marvelous little device. I saw some of the applications for this where they'll mount this in the middle of a drivetrain between two screws that they want to synchronize. Like if you have a XY table and you have two lead screws, you know, one on the left and one on the right, and you need to sync them up. You can put this between the right angle drive and sync them up. Or there's any number of uses for something like this. No backlash, infinitely adjustable, very high reduction ratio. Nice little device. I thought you'd all like to see that. Now back to putting my Bridgeport back together. Thanks for watching.